All right, I'm going to help you through the first page here of the Chapter 7 individual assessment. I'm going to get the problem set up for you, get you started. If you have any further questions after this, of course, you can come and ask me, but hopefully this video will be enough to get you set up with to find the right answer. So the first question says, Mr. Darcy could knit 6 ugly holiday sweaters in 120 minutes, and they want to know how long it will take him to knit 8 ugly holiday sweaters. So we are going to grab our numbers here. It's 6 sweaters per 120 minutes, and we want to know how long it takes to do 8 sweaters. So that's our question. So what we actually want to know, we know how many sweaters, we want to know how many minutes. And when we do these rate problems, you want to identify what term you want to solve for. In this case, you have 2 terms. You have sweaters and you have minutes. Well, the answer tells us how many sweaters there will be. The answer the question sets us up that the answer will have 8 sweaters. But we want to know how many minutes. Whenever you do that, once you identify which term you want to solve for, you put that term on top of the rate. So you're going to put the number of minutes in the numerator and number of sweaters in the denominator. And when you do this division problem here, so for example, this would equal 120 over 6, right? 120 minutes per 6 sweaters. When you do that actual division problem, 120 divided by 6, that's going to tell you how long to knit 1 sweater. And then once you figure that out, it's a simple multiplication problem. You just take how long it takes to knit 1 sweater and you multiply it by 8, which is the number of sweaters available, or the number of sweaters that you want to know how long it takes to make. And so that's how you're going to solve that one. You figure out how long it takes to make 1 sweater by setting up the rate, and then you just do the division, and then you multiply it by the number of sweaters that you want. Problem number 2 says, after a school party, you and 2 of your friends got to take home 5/6 of a pizza. How much of a pizza will you get if you get to split what you have evenly? So this is a dividing fractions problem again. Make your prediction first. With all these problems, including the first one too, you should always make a prediction first to make sure that you get a reasonable answer. And if your answer is not reasonable, or your answer does not match your prediction, you should trust your prediction over your calculation at this point. A lot of people are making calculation errors, but you're all very good at making predictions. So, for example, if you have 5/6 of a pizza, you have less than 1 pizza, right? You almost have a pizza, but you're missing 1/6 of it. If you divide it between you and 2 of your friends, or 3 people, then you should predict that you're going to have around 1/3 of a pizza, slightly less than 1/3 of a pizza, right? If you had a whole pizza and cut it into thirds, let me draw a picture here. If you have a whole pizza and you cut it into thirds, between 3 people, each person would get 1/3, 1/3, and 1/3. But if you're missing 5/6 of a pizza, that's not a good way to do that. This is just for visual sense. I'm not going to bother being exact. But if you're missing 5/6 of a pizza and you cut that into thirds, you're going to have less than 1/3 pizza each time. Okay, so you want to predict that you're going to be slightly less than 1/3 of a pizza. A lot of you guys gave me answers like 1 2/3 pizzas, which I can see where your thinking is going, but that should be a big alarm that you're not going to divide less than a whole pizza by 3 and end up with more than a pizza. So trust your intuition and think about your answer before you finalize it. Anyway, it's really as simple as 5/6, pen here, 5/6 of a pizza divided by 3 people. And remember, when you do this division, that this can also equal 3 over 1. So you're basically saying take this 5/6 of pizza and cut it up into 3 pieces. Another big error that I saw was people took this to imply that the pizza is cut into 6 slices. And one of those slices is missing. That's not true. I mean, it could be, of course, but it does not imply that. You could have ordered a pizza from, say, Donato's, where it's cut into, like 20 pieces or something like that. Could have gotten one of those fancy pizzas from a restaurant that comes out, with the tomatoes and everything and some arugula on top, and you get a whole pizza, you eat it with a knife and fork. There's no way to know. So don't assume, unless it says is sliced into 6 pieces and it asks for how many slices, don't assume that you're going to give me a number of slices. You need to assume, if I ask for how much of the pizza, you should give me a fraction of the pizza. So you would just do this division problem. You could find a common denominator by turning this into a 6. You could flip and multiply. And you could, of course, do the supergiant 1. So there are lots of options for that one. Number 3 says it took 1/4 of a gallon of gas to drive my car 3.5 miles. How much gas will it take to drive 1 mile? Again, I can't stress enough, make your prediction first. If it's 1/4 of a gallon to drive 3.5 miles, how many gallons to drive 1 mile? Well, it's going to be less than 1/4 of a gallon. It's going to be maybe around 1/3 of 1/4 of a gallon. So that would be like 1/12 of a gallon, in that range. Something. It's going to be a very small fraction of a gallon, because it's a small fraction of a gallon to get to 3.5 miles. So it's going to be an even smaller fraction to get to 1 mile. And again, I saw a lot of people give me like 14 gallons to drive 1 mile, which I can see your math and how you got there, but you shouldn't have written that answer down. I would never, ever drive a car that went 1 mile on 14, or took 14 gallons to go 1 mile. That would not be a very good car. Anyway, in this case, it's hard to visualize. You got your 1/4 gallon, and you got 3.5 miles, which you want to immediately convert that to an improper fraction. So 3 times 2 is 6, plus the other 1/2, so that's going to be 7.5 miles. You immediately want to convert that to an improper fraction so you can do something with it. This 3.5 miles, it shows you that it's a nice, about 3 miles, a little bit more than 3 miles. This, however, is what you want to calculate with. So it's hard to see, am I cutting up 1/4 of a gallon into 7.5 pieces, or am I cutting 7.5 pieces into 1/4 of a gallon? With these kinds of problems, when it's not something clear like pizza, then it's easier to think of it as a rate. And when you're setting up a rate problem, you want to think of, your 2 units. You've got your gallons and you've got your miles. Which one do I want to solve for? Well, the answer is also going to be a rate of gallons per mile. But in this case, we're given how many miles. It's 1 mile. So our answer is going to contain 1 mile. We don't know how many gallons it's going to contain. So you want the unknown number, or the unknown term, on top. Because when you end up solving the problem, you're going to be left with the denominator turning into 1. So whatever you put in the denominator is going to turn into 1. And whatever you put on the top is going to be the solution. So in this case, your 7/2 miles is going to turn into 1 mile, which is what we want. Put that over here. And our 1/4 gallon is going to turn into our answer. How many gallons? Because we put that on top. If you accidentally reversed it and put the miles on the top and the gallons on the bottom, your answer would be down here in the denominator, which would be fine as long as you made your prediction. You recognize, oh, my answer's down here in the denominator. I'm going to pull that out and write that as my answer. But if you put it on top, then your answer is going to be what the division problem equals. So when you hit your calculator or when you solve it, then you know it's there. So then what do you do here? Well, you need to do something that will turn the denominator into 1, which could very well just be do the division problem, in which case you would do 1/4 divided by 7 over 2. And you have several strategies to solve that. You could do common denominator by turning the 2 into a 4. You can flip and multiply. Or a lot of people looked at it this way, which I love to see, is what number can go here that will make this 1. If you can figure out what number to multiply the denominator by to make this 1, and then of course put that same number up here, it has to be the exact same number so that this equals 1, then you can get the answer. Again, you're only multiplying by 1, so you're not changing the problem. So you have lots of options of how to solve it, but essentially you want to set up your rate with what you're looking to solve on the top and what you need to turn into 1 on the bottom. So we want to know how many gallons per mile, and so we put the gallons on the top and the miles on the bottom. Number 4 gave a surprisingly large amount of problems, and I think it's just because you were thinking in terms of fractions, and since we're doing multiplying and division fractions, there must be some multiplication or division problem in here. But if you read the question, it's actually as simple as addition. The smallest pumpkin at the festival weighed in at 1/8 of a pound, while the heaviest weighed in at 1,810 and 3/8 pounds more than that. How much did the heaviest pumpkin weigh? So there's no multiplication or division necessary. I've got my smallest pumpkin right here. So here's my smallest pumpkin, and it's very small. And then I've got my biggest pumpkin up here, and it's very big. And we know that this pumpkin weighs 1/8 of a pound. So we'll just imagine they're both sitting on the same floor. So this is 1/8 of a pound. And this pumpkin here is 1,810 and 3/8 pounds larger or heavier than the other one. So how much does this one weigh? Well, it's going to be 1,810 and 3/8 plus this additional 1/8, right? Right here is 1/8 of a pound. And then right here, the distance between here and here, the max weight, is 1,810 and 3/8. I think you guys would have been great if this were a distance problem. It said the shortest pumpkin was 1/8 inches tall, and the tallest one was 1,810 and 3/8 inches taller. You probably would have gotten it, but for some reason, because it was weight, it seemed to confuse you. Well, what's this plus this? 1,810 and 3/8 plus 1/8. Well, adding 1/8 to 3/8 isn't going to bump this up to 1,811. So it's just going to be 1,810 and 4/8, which of course is reduced to 1,810 and a half. And of course, pounds. All right, so that's all there is to that one. Just wanted to make sure that you're still thinking numbers